Hello and welcome to our Equilibrium Lab. It's all about balance. So we're going to study 3 different aqueous equilibriums. AQ just means we're dealing with ions. Everything's soluble. So for our first one, we're going to start by adding water to a test tube. This is what you're missing, the excitement. Test tube, water. Did you see that? I even wore gloves to make sure I was extra careful. And now, this is actually the really exciting part. We're going to add a few crystals of iron nitrate. And there we go. And look, it's kind of, can you even see the pale yellow color? It's a pale yellow color. Let's write that. Now, we're going to see if we can change the color. We're going to add a little bit of KFCN. Just 1 drop will do it. Here we go. Isn't that pretty? So what happened is as soon as the iron and that thiocyanide come in contact, they make a new ion. And this one is blood red. So as we add a reactant, we increase by adding the SCN. We're going to actually shift it and make our product, which is blood red. So the trick is, can we get it to shift back? Well, let's try adding some NaOH. Now, NaOH is not part of this equilibrium. Oh, a quick comment, because this is important and it is a question. This is potassium thiocyanide. Yeah, I don't show the potassium in there, and this is iron nitrate. So what happened to the nitrate and what happened to the potassium? Well, they're what's called spectators. They're just there. They're floating around. They had no interest in anything. So remember all those doubles? They were not really the swingers, because not everything hooks up. The potassium, the 1A's, potassium, sodium, lithium, they're always swimming. Same with hydrogen. That's why we show them what they're. And nitrate, Nick is like the best swimmer of all. Nitrate is always swimming, so we just leave it out of the overall equilibrium. So now what I'm going to add is some sodium hydroxide. Let's see if this works. Worked for the guy in the video. I've never tried it before. So the sodium doesn't matter. The sodium's a 1A. It's a forever ion. It loves being aqueous. It just keeps swimming. But the hydroxide, if we're lucky, the hydroxide should bind to the iron ion. So we have a true equilibrium here. We have all our ions present. And that's a key for us to be in equilibrium. We should start binding iron. And as we pull the iron out, oh, it's gonna work. Do you see that? The color changed. We're getting back to the yellow. So even though the hydroxide's not part of this, oops, we got it plugged. It's like live action, high quality. It's plugged, there we go. And so it's kind of cool. You can see the iron thiocyanide, the product, is hanging out there. And then as we swirl it, not over my computer, hopefully. Oh, we've got definitely turned clear. Should we see it all again? That was so fun. So if we start with a little bit, oh, actually, we'll do it this way this time. Because I have some solid potassium thiocyanide. Add some of that to our water that I had already. And look, it dissolved. It has no color. But if we add this, iron nitrate, which has a color. You watching? Whoa. Time I added 2 drops. That's pretty blood red. So again, start with the reactant, we add the other reactant, it shifts. When I start adding the sodium hydroxide, you can see the colors are definitely different. When I add the sodium hydroxide, the color got lighter. Not because I'm diluting it. I'm going to prove to you it's not because I'm diluting it, but because as I take away a reactant, the equilibrium, it wants to stay in balance. It wants everything to be there. I'm a Libra. Remember my birthday was back like a month ago, 2 months ago. I don't even know now. And I want everything to stay in balance. So it wants to keep it in balance. So it's shifted back, trying to make more iron. So what if we added something? I have sodium nitrate. Remember what I said about Nick? Nick is always swimming. So the nitrate's always swimming, and so is the sodium. In fact, we can take the lid off this and just pour it in to the one that's blood red. It didn't dilute. It's still the same blood red color. Whereas the other one that I added hydroxide to, the hydroxide again, isn't part of this equilibrium, just pulls the iron out. And the whole thing has to shift that way. Adding something that's not interested in anything, like sodium nitrate, it just stays where it is, and we see the blood red. All right, you ready to move on to the next one? You can pause me and answer your questions about why. So it shifts, you add a reactant, shifts towards the product. You decrease the reactant, it shifts towards the reactant. You add something that nobody's interested in, nothing happens. It maintains its balance. All right, so now we're going to work with nickel nitrate. So, in our equilibrium, why is there no nitrate? Oh, because he's Nick. They gave me lousy droppers. Did you count? Was that 10? Let's do 20. Because I'm feeling lucky today. And then we're going to add a few drops of NH3. So, it's kind of a periwinkle green, a light green. Let's write our colors up there. So, is that periwinkle? I think so. Which is a light green. For those of you who don't know your color scale, which could be your teacher. Let's put these away. Should put the lids on. Does that drive anybody else crazy? This could be the bonus. I'm pretty sure I dressed like this for you all once before. I kind of feel like this is my equilibrium outfit. So that would be the bonus question. What other video did I make where I dressed up like this? Because when I was dressing up, I kind of remember doing this recently. Maybe it was in a dream, and who knows. All right. So we're going to add, not the NaOH, the NH3. So we're going to add some NH3, and what we're going to make is this new special ion. Oh, isn't that a beautiful color? So it's now a blue. You can say any color blue you want. It's blue. It definitely was green before. So we went from the green to a blue. If you want, I can put some more of the green in the test tube next door so you can see the difference. We should have gone with small test tubes. We could actually still do that. But can you see? This was our green, our starting point. Maybe we should swap them. And then we added the NH3. Now, I didn't ask you the question this time about that. We're going to add some HCl. Now, you might be going, HCl? That's not part of it. Nothing's going to happen. I'm going to add it. Let's see. Just need a few drops. Ooh, that's pretty cool. There's like this effervescent smoke. Do you see the smoke? It's changing. It's not as blue as it was. What happened to the blue? That's actually another lab. It's an oxidation reduction lab. But look, it went back to the green. It's back to the same color we started with. What happened? Well, that's the question. Our if you keep watching to give me 10 points. HCl is an acid. It's a strong acid. So what in this equation is a base? Well, this is a weak base. Did you write in your color here? You can do an aquamarine, which means blue. For those of you who are like, want to keep it to Roy G. Biv. All right, this is a weak base. What happens when we add the HCl? The HCl says, ooh, I like this. I like nitrogen. It gives the nitrogen a hydrogen, and this NH3 is no longer there. The NH3 can no longer combine with the nickel because it's now reacting with the HCl. So if we decrease the NH3, what's going to happen according to LeChatelier? Well, you can see. We're going to see a shift. It's going to always shift to the side that we're missing. If we add, it will move it forward. These, by the way, are called complex ions. We worked with simple ions like sodium chloride, but there are times, this is actually where the really cool stuff happens, and where you see all the colors of gemstones, is you make more complicated ions. And that would be an example here. So NH3 is not technically an ion, but this is called a ligand or a ligand. And so the nickel happens with the transition elements, the ones in the middle. They form these ligands around it. So it forms this beautiful octahedral shape around the nickel. And we see the beautiful blue color. And without that, now, if we were really lucky, if we added a strong base, we should be able to go back. Because that should, but usually it's really hard to see the color. Oh, we're getting kind of a blue back. Yeah, so when we added the strong base, we're going back to blue. It's really cool because it's in 2 layers, because now it's just like, I should have kept the 2 layers. All right, one more. Ready? Gnomes are here. The gnomes are very sad because this is our last day in lab together. Oh, but some of you will be with me next term. And maybe we'll finally, so we're going to add, I didn't read the instructions, how many drops. Does anybody count? You can put me back in slow motion, see if I added the right amount. And now we are going to add 12 molar HCl. 12 molar. This is the big stuff. That's why it's in this special glass jar. So, it's pink. If you want, you can come up with a clever name for pink. Is there a clever name? There's got to be. It's pink. All right. You can say carnation pink. Carnations are pink. I'm trying to think. I usually have a bubblegum pink. Let's go with that. You know, we have to keep the pink there because some bubblegum is different colors. It's kind of gross stuff. All right. So, I'm going to add drop. This is like the big deal. Let's just add a bunch of drops. Well, nothing happened. I was getting a little confident. It kind of turned to purple. You might have to start over. Your teacher might have to follow instructions. It's definitely a purple now. Let's read the instructions. 5 drops. And then 12 drops. So that's probably why. All right. That was a good lesson. Just always follow the instructions. 5. That bottle's looking pretty bad. And then, what are we doing here? 12 drops of 12 molar. This is usually where I'll come over and talk to you and distract you and see. So we kind of got it. You know, I'm feeling like my 12 molar is not 12 molar. Let's add 12 more drops. I go through this with the lab. All right, we're going to put you on pause. I'm going to go find another bottle of 12 molar HCl. It was set up. Oops, doing pause, pause, pause. I can't pause with gloves on. All right, I'm back. I got more 12 molar. I also figured out how to get it to work. So, we'll add our 5 drops. You counting? 1, 2, 3, 4, 5. And then, our 12 molar HCl. 12 drops. You can talk to me while I'm doing it. Is that 12? I kind of lost track. But didn't look like much happened. It still must have been kind of reject, but this is the cool part. All right, because I figured out how to make it work. So I have some boiling water here. Watch this. Hopefully it works. Oh, it's working. Can you see? It's turning blue. So apparently it's just a little chilly in here, but it's not. It's freaking warm in here. All right. So look at that beautiful blue color. That was part of the next question. So, yeah, that was the one that I kept adding and adding. That, look at that. It's beautiful blue. That's the color of this. This beautiful blue color. And then if we put it in some warm water, cool water, room temperature water, let's turn this off. Help to cool it down. We should be able to get it back to the pink. Maybe. Oh, actually, you know what? I didn't want to get it back to the pink yet. Let's get back to the hot. Do you want to watch that again? Because it was really cool watching it in slow motion. It's really hot. Can you see it? It's turning blue. So is it X or N? No. The heat is making it turn the blue. Oh, I lost my pink pen. You can make, that's a really pretty blue color. I don't know what color blue that is. Teacher got a little flustered. But if I add water, I lose the blue. It goes back to the bubblegum pink. But why? H2O shouldn't be part of our whole equilibrium equation. And it's really not, because it's a liquid. But this is a really interesting fact about this. When you write your K expression, you take them to the exponent of that koi fish. And this has 4 koi fish, right? 1 fish, 2 fish, 3 fish, 4 fish. So it's going to be taken not 4 times, but koi fish to the 4th power. So when I add some water, everything cuts in half. But this gets cut in half. Its concentration to the 4th power. That means it's now at 1/16. So anything that we do that affects the chloride is going to have the greatest effect on the equilibrium. So even though when I added the water, it cut everything down, it had the biggest effect on this, and so it shifts towards that. Let's see if we can get it to turn blue again. Is this my hot water? It's a little warm. And there we have it. Oh, might have added too much water. Like, this is that thing where your teacher says, never ever experiment like this. Yeah, we got clear. There's a little bit of blue. I think that's the reflection of me. All right, there is a point where I don't know what I was going to say. Oh, I got it. I just need to add a little bit more chloride because we had diluted the chloride too much. There we go. And that's all I got for you because I'm not going to do the nitrous NO2 one because that's a really nasty gas. I love you all. You are amazing, and I'll see you soon. Bye.